Welcome to Khetz tutorials. In this video, I'll be continuing with my LTspice series and I'll be covering AC analysis. Now, my aim for this video isn't to dive into specifics of the circuit that I'll show you, but I just want to introduce the AC analysis method of simulation. So in this video, I'll be using an LC filter, an RC filter actually, and if you aren't familiar with filters, don't worry about it. I'll try as much as I can to explain what I'm doing or what I'll show you is about. Or I'll just try to give you an overview so you can follow. So now let's start with our circuit. We now have all the tools to actually help us understand simulation. So let's focus on the simulation, but I will talk about the circuit itself. So let's put out a voltage source, a resistor, Control R to rotate that, C for capacitor, place it there. Now I'll just connect all of these things, F3 for the wires, then in a while we'll just assign values to each of these components. Okay, so just want to connect with that, and don't forget to ground your circuit. Alright, cool. Press escape, right click on your voltage source, go to advanced. So this is how you'd set up your AC analysis. You have to introduce an AC signal, so you can give it any voltage value. Just give it a voltage value of 1, which is quite standard for most cases. So you can go ahead and use that. So I am building a filter. So this is specifically a low pass filter, which I'm going to build here, with a chosen value of 1K, and if you do the calculations related to filter design, which I don't want to dive into, for a cutoff of about 1 kilohertz, then this should be this number. So let me just quickly explain what I am doing, and perhaps that will help. So with this AC analysis, you are able to see the frequency response of your circuit. Just like we did when we covered DC sweep, where we were stepping through voltage values, you're able to see the behavior of your circuit as you change the voltages. So from a low voltage to a high voltage. The same applies in the frequency domain. You can actually see how your circuit behaves by setting a start frequency and a stop frequency. And the output of that is called a Bode plot. So now filters are frequency selective. So a low pass filter specifically allows frequencies to pass through from, let's say, 0 to the cutoff of the frequency that you specify as your cutoff. So from the cutoff, everything above that will be taken out, or it will be attenuated or reduced in amplitude. And that is what we expect to see here. So I previously mentioned that this filter is expected to have a cutoff of, this should be nano, so n at the end. This filter is expected to have a cutoff of 1 kilohertz. So after 1 kilohertz, or after the 1 kilohertz mark, we expect attenuation, or we expect a decrease in magnitude. So now let's set up our AC analysis. I hope that makes sense, and it will make more sense when we actually run the simulation. So now let's come to our simulation. Now you're going to go to AC analysis, type of sweep, set that to octave. Doesn't really matter, to be honest. Just that octave is quite common it's commonly used, and we're going to just set a random value of 10 points per octave, random starting point of about 10 hertz, and let's stop at, let's say, 5 kilohertz. So now let's see the response of our circuit from 10 hertz to 5 kilohertz. So you're going to probe this point here, which would essentially be the point where you measure from. So now if you press that point, you'd see that we have a green graph or green profile over here, which is flat. So let me adjust this to go up to, let's say, 2 dB. And if I do that, you can clearly see this line, the green line over there. So that is our magnitude line, and that is what you'd mostly be interested in, right? And if we have a look at this, then we can press on that to actually pull out our cursors. So at this point, as I mentioned with regards to filters, so if you are interested, please follow along. Now, any frequency which is below 1 kilohertz will essentially maintain its amplitude. So if you have a sinusoid, it will stay the same if you pass it through this circuit that we have here. So its amplitude, let's say its amplitude is 5 volts peak to peak, then that will be 5, 5, 5, 5. But once it gets here, as you can see, the amplitude, the magnitude is actually decreasing, which means there's attenuation. That is what a low pass filter does. It essentially attenuates after a certain point and allows everything which is below that cutoff to pass through. And theoretically, we're supposed to go to minus 3 dB. So if you look at the values which are associated with my cursor's position, you'd see that I am at about minus 3 dB over there. And the frequency at this point is about 1 kilohertz, which means my circuit actually did achieve a cutoff of 1 kilohertz. So this is very useful if you're going to do filter designs, if you are interested in the frequency response of your circuits and you're trying to analyze that. You'd set up an AC analysis, you'd inject an AC signal, then you'd run your simulation based on your frequency range. So just make sure that your frequency is set up accordingly. So if you had higher frequencies, obviously you wouldn't have stopped at 5 kilohertz, it would have been higher. So just look out for that. So this is my simple example of an AC analysis. And once again, you can change what you want to see over here. So we're currently plotting a board plot. You can change it to a Nyquist plot, Cartesian plot, or any other thing. And each of these will probably have different units, and you can see what will happen based on those. So play around with those and see what actually happens. But this is just a basic overview of an AC analysis. If you found this video useful, just give it a thumbs up. If you have any questions, feel free to ask in the comment section, and I will see you in the next video.